welcome. I'll be holding 2 talks. The first one is going to be about Python ClojureScript and what you can achieve there in terms of feedback loops. And the second talk is going about state machines. And all of these talks are super serious. So first talk is the feedback loop. So Python ClojureScript. So both languages are very well suited to tight feedback loops, specifically because both have REPLs. So for the people who don't know, REPL means read, eval, print loop, and is the best feedback loop that you can have for programming languages. Both are very stable languages, and they both have massive ecosystems. So ClojureScript in particular piggybacks on top of JavaScript. So everything that's existing in JavaScript, you have access to. And both languages are highly pragmatic. They're meant to get stuff done. So feedback loops, time matters. Programming has one phase that's about exploring. You don't really know yet what the solution is supposed to be. And you then find out, oh, this is what I want it to be, and you then stabilize it. And exploring typically means looking into closely, you scrutinize things, and you examine it very closely. And the problem with feedback loops is that you cannot examine what has not been materialized. So this is from extreme programming. So typically release plans, you have a feedback loop of a month or more. So you initiate something and you don't know what's happened until a month or more later. And as you go down in the stack, it's months, weeks, and so on and so forth. And then they lie here because they say seconds for code. I think everyone knows that that's not really true. So the length of the feedback loop determines how fast you can course correct. And this is the golden feedback. You immediately get back what you want. And the more process involved in giving feedback, the longer things take. So the goal is to reduce process as much as possible to get tight feedback loops. If you can cut them out completely, that's even better. So this is a typical feedback loop for programming. You write some input into your IDE or text editor. Then you have a small delay because it's compiling or interpreting or reloading. And then you get the feedback. Depending on the programming language, this can be a couple of seconds up to hours. The gaming industry, for example, the big AAA games are notorious for having a feedback loop of 1 day. So you write your code, and then you find out the next day when it's compiled, did this work? And that's why they're so bloody expensive to develop. And this is the golden feedback rule. Like this is possible to get with a REPL, where you immediately get the input, it's immediately evaluated, and print. In this case, you have some kind of input. You can go to std out, or it can go to any channel really. This is a very common feedback loop, unfortunately. You have an architect who's giving input to the programmer, and there's no feedback loop back to the architect. People are looking for a solution. Personally, I think the architect should actually program a little bit more, maybe. Here we have a slightly larger project with lots of feedback loops. And a project manager, this is his job to manage this. So it's a lot of fun when you have a feedback loop going from the UX specialist all the way down to the DBA. And he's saying, no, that's not possible. And I think this feedback loop is where I'm hoping to be able to offer a solution that doesn't get rid of the feedback loop, but it severely reduces it. So this is a very typical feedback loop for UI. You have a backend. You might have some kind of migration for a database. Does this work? Yeah? Oh, it doesn't really show. There's a delay because you have to do the migration to the database. If it's a big database that you're working with, that takes a lot of time. It might not work, so you have to go back. Then get the feedback back to the backend. And then you write some code. You go through that loop. First now, you can do the actual work on the front end and see, is this working? So the feedback loop goes over to the front end. You go through that loop. And then now you can test against the backend. Does this work? And the answer is no. So we go back here. OK, I can now test it again. Now it didn't work. So that takes up an awful lot of time. And again, it's excavated by the programming languages they're using. So ClojureScript, released 2011. It uses the functional programming paradigm. For the people who do not know, functional programming comes from math, really. It's lambda calculus. And basically, the key part about it is that you want to send input into a function. It does the computations, returns the computation, and has no side effects. No side effects at all. Data in ClojureScript is immutable by default. There is very clever mechanics underneath to make sure that it's fast enough. And I'd like to make the analogy to C and pointers, C++ and pointers, where you used to manage all memory manually. Then the industry moved towards languages that have managed memory. You want a garbage collector. You don't want to manage memory manually. It's a similar thing for state. You still have constructs, so you can mutate if you need to be. But there's an awful lot of stuff you can do without actually having to mutate the data. And it transpires to JavaScript. So it's designed to be hosted on a platform. So you have always full interoperability with the host platform, in this case JavaScript. There are other variants of Clojure as well. And there's a lot more to talk about it, but for the sake of the talk, we'll skip that. So React, it's unveiled 2013. It uses a view as a function. Oh, that works really well with functional programming, because functional programming is, you have a function, you take some input, you return the result, and then there are some updates on the side. But really, really well working. And because you have full interoperability with JavaScript, you can reuse all the React components that exist in the ecosystem. And we're going to have a demo. So I wrote a small demo, troller, dating for trolls. So we're going to write the dating site for trolls. We're not really sure about step 2, but step 3 is going to be profit. We're going to make so much money. So it's Regent and Reframe for the front end. Regent is the wrapper around React. And Reframe is basically some basic structure for an SPA, so single page application. And we use Django REST framework for the backend. Right, there we go. So we have a typical backend for the typical Django REST framework for the backend. And we have likes, messages, and profiles. Profiles look a little bit like this. We have APIs that are already set up. It's very standard list, REST API, list, get, so forth. And here's our beautiful application. So feedback loops. One of the things that Reframe offers is a dashboard where you have access to the database. So in this case, if I log in, wait, I need to do that. My database is updated. So I can add a path inspector. In this case, I can have a look at everything that's in there. And see all of the profiles. Because there's not really anything on the backend that filters this. And this is event-based. So I can jump back among the events. In this case, nothing is really happening, but okay, let's redo that one. Okay. This is all part of the demo. So let's see. Something is wrong. Which am I? I'm a user logged in. What's my status? I don't have a status. Why do I not have a status? Okay, let's get hardcore. Okay, users. I have my profile. I am logged in. Oh wait, which is the view? That's what I need to look at. That's nil. So if we cheat, okay, there we go. So, well, technical problems. What I did here though, I made a change to the code and it immediately updated the front end. And I'm still logged in. I haven't lost my state. So in this case, I should be able to move to my profile. And that's not working. This is really good. So you get a live session of debugging. Let's see, util, I'm in menu. When I click, I do a dispatch. Menu status. Active. So here I'm going through the events and it changes my, what on earth? So this should be, Wait, it's the controller view. HDB. Wait. Controller view. Okay, that one is working. Okay, so I actually have the database correct. And I need to go to subs maybe. Controller view. Views. Controller view. So if I go to my repo and I am in controller views. So now I am actually in the application and I've navigated to this namespace. So everything in this namespace I have now access to. So I can actually check if I get the correct result. And I do. So if I do some view main, view profile. Right. This would also explain something. There we go. See? It's not so hard. So views, profile. So here I have my profile. But due to it being a dating site, I should obviously be able to see my my image. Because otherwise, what's the point? So you've already seen some of this now, right? But I've now written in that I want to see the image. I haven't actually saved anything yet. And I do this, and I get my image. So what happens is that I have another program here that watches this, watches for changes. When I save a file, it then transpiles it to JavaScript. It's sent to the browser, and a refresh is happening. But because the state is elsewhere, and it's immutable by default, so even if it refreshes, it typically doesn't actually disappear. I can work with the database without having to do any reloads. And as already demonstrated, I can actually programmatically go into the namespace in the running application on the browser and programmatically do things. So I can make, if I'm developing a new feature, before going even into the UI, I can fire everything up and start to, I want to have this event. I would like to pull data from here. I want to put the data over here, and then actually wire everything together. Then I can write the actual graphical user interface, which tends to be a little bit icky. There's also, it supports live refresh of styling as well. So if you want to do some styling, you can do that on the fly and see how it works out. So let's see how we're doing on time. Okay. So we can go to messages. So let me I have my menu out there, and we want to go to the menu, and then I want to have a look at the messages. So let's go to the messages, and there's nothing there. So I would like to see that this is actually working. So I'm going to go to messages, and I'm just going to add one from, I think it's firmware to admin. And there. Let me save. Okay, so then we take a look in here. Is this working? Messages, are they there? List maybe. Right, so we have the message. It's not been populated though. So if I go to messages, and I'm in my REPL, I navigate to the namespace. Let's see, did I do anything here? I believe I did, because I was very crafty, and I believe this should work. So I can do a data push. So I do a dispatch, which is just telling reframe, do something, and then I need to capture it afterwards. So I want to push data, and I wanted to push it to API dating messages create. Oh, list. I don't have to do anything. And let's go down here. Let's see. What did I wire it up against? Event rest. Data messages. Right, so hopefully this works. Method post not allowed. Right, yeah, that works too. So I have a message here telling me that I'm not allowed to use post. This is very true. So I should probably get data pull. And I have my message. And then we can go into chat and use chat. Right, so this should be working. So I have a server running for MQTT. So if I connect, let's see, client equals, okay, we're connected, and then we do a publish. Right, I should actually be on the chat. Right, and I need to update that in views. So we're now here, and we have our first message. And we can do another one. Right, so from here, I've done the entire feedback loop. I have everything on the back end. I have everything on the front end. All I need to do is just wire it up. But I've done the phase of exploring with a very tight feedback loop. There were some errors, all part of the demo. And I could see very fast, like, okay, this is what's wrong. Like I made a mistake here. And typically speaking, I find this, like the really tight feedback loops, allows you to explore ideas. It allows you to see what went wrong. And the cost of mistakes are very low. So you just, oh, I made a mistake. Okay, I'll just throw that away, try something new.